So, my name is Sergey. I work at Badu as a project manager in Moscow office, and we also have an office in London doing primarily marketing and advertising, and all the research and development is done mainly in Moscow. And Peter Zaitsev invited me to do an extensive talk on handler socket. So I finally made like 100 and a while slides, and like it will take 3 hours. So cut half of the slides and 60% of the talk to fit in 40 minutes. So it will be a little bit tough. Thanks for coming. So the talk is called MySQL and handler socket is love and NoSQL. We all know SQL. SQL is cool, definitely. A little bit complicated. And has lots of cool features like this. Aggregates, subqueries, joins, complicated where conditions, stored procedures, transactions, and all this stuff. But for a general website, and the company I'm working for is definitely a website, most of the queries, like 90%, are very simple, like this one. So usually you cache results in memcached to avoid database overloading. But what if I tell you that for these simple queries there's another approach which is much simpler, and it's called handler socket. So what it is? First of all, it's a MySQL plugin with direct access to InnoDB inner layer. It opens its own socket, has its own protocol commands and functionality, and has no SQL support at all. So, as everything, it has its own pros and cons. Here's the pros. First of all, it's much faster than SQL processing, because it avoids query planning, index selecting, SQL parsing, and all that old stuff. It batch processes requests, which makes it further faster. So it packs lots of requests from different connections into one big into one big transaction. Is it better, or should I? Yeah?
It's okay like that.
Okay. It has very compact binary protocol, so it saves bytes and network traffic for you. It withstands high load and simultaneously opening like 10,000 of connections, and it allows you to access the same tables via SQL layer at the same time. It works okay with replications at binary log level, and as a big plus, it's bundled with Percona server. So, finally, you use handler socket and there is no need for memcached. So you get extra memory and you have no memcached. Fire your system administrator. You have no duplicate data. So currently, now you have all your data being consistent. Handler socket cons. It's InnoDB extra DB only, and it was meant to be, but it started to support other storage engine, but its still support is buggy. It has no transactions, no stored procedures, and lots of MySQL core features like joins are also not supported. Sorry. It has no commercial support. That's very pity. You can pay money to fix bugs. I tried to, but I failed. And it's a little bit immature, sometimes that immature, has quite a big bunch of bugs. Very unclear documentation, and half of this talk is dedicated to making this documentation clear to you, because I spent 2 weeks finally trying to break it in every way I could, and to find the way it works, to read all the sources. Work logic and protocol change from time to time with no evidence. So usually the protocol is the same, but if you update Percona server, it can stop working. Sorry. And the final part, the final item and topic, it sometimes block table modifications and blocks table locking. which is very, very pity. So what handler socket is not? Actually, it's not a key-value document store, because you can build your own using MySQL and handler socket with your own dings and whistles. It's not a binary SQL layer. It has its own protocol, own commands, own features. It's definitely not a tool for complex queries. Forget about joins, forget about transactions, about subqueries. This is pity, but it is as it is. It's not a tool for creating, modifying tables just because there is no data definition language analog at all in handler socket. It's not meant for hosting usage because its authentication is very, very limited. So finally you can't share resources properly, and everybody is accessing all the data. Let's drill inside handler socket. Here is a big and hard diagram. We'll stop a little bit with this. Here is a typical MySQL server with handler socket plugin enabled, and here is your web application. So you can use SQL layer as always and access port 3306 to execute complex SQL queries, but handler socket also gives you port 9998 and port 999 with a few set of worker threads. Each of these threads accepts thousands of connections and works with them well, okay, and simultaneously. You need your own client library, which supports handler socket binary protocol, or write your own or get one from the internet. There is a bunch of them. Handler socket avoids SQL parsing, opening tables a little bit. Making query plans definitely, closing tables a little bit. But finally in MySQL you have a thread for a connection, so you can't open thousands of them. And in handler socket you usually use 16 threads, that's okay, on a very big server, like a 24-core machine. Protocol was very concise and compact, so it saves bytes for you. And finally, after MySQL has done its own long and hard job on choosing indexes, making query plans, they both access InnoDB or XtraDB at the same low level. So finally, it's just handler socket is just replacement for hard SQL logic in MySQL. So you can kick out my memcached and access the same tables, the same data, and work with it via handler socket simultaneously. And here are like some reader handler socket thread working cycle diagram. So for a typical read thread and read cycle, handler socket reads a bunch of requests from many clients, one from every socket, if there are any. It locks the table and gets a read view on the table. There is no deadlocks in here, they promised me. Then it executes many requests on this locked table, unlocks the table, and returns responses to clients. So it batch processes requests and locks and unlocks tables only once per cycle, oppositely to as MySQL does it. In the write cycle, we use a transaction definitely, so you can't control it, but it's used inside handler socket. It reads requests from clients, one from every socket. Locks database, locks tables for write, starts a transaction, executes this bunch of requests, commits the transaction, unlocks tables, and returns responses to you. So this works really fast. One feature that I need to mention is if you will MySQL somehow dared to have a very complicated request because it works in a cycle and locks and unlocks tables and batch processes requests in a bunch. You will receive all the responses from this cycle simultaneously. So it's very hard to do a complex long query on handler socket, but if you do it, every socket which entered this cycle will receive responses at the same time after all the queries are completed. But usually it's a fraction of a millisecond. Let's discuss handler socket MySQL interoperability. So when using handler socket, you read consistent data via HS and via SQL layer. Everything is consistent, everything is run in transaction, everything is perfectly cool. Handler socket supports MySQL replication at binary log level, works okay. Even master, we use it at Badu. Auto increment is also supported and works okay. Current builds start invalidating query cache, so this is not a problem anymore. MySQL users and permissions are not supported. It has its own authorization system, very limited. Sorry. And table locking, where handler socket and logs acquired through SQL layer will conflict. So please be very careful when you do alter table and when you do log tables write. This doesn't count for log tables read, but for log tables write definitely. If it's one of the peculiarity. If you want to alter table, you are working with handler socket currently, or you were working for last like couple hours, you'd better shut down the database, start it in single user mode, do alter table, and then shut down and bring it up again with handler socket enabled. Otherwise, your alter table will hang entirely and will hang for a couple hours or a couple days. When I usually use a second approach, I just copy the table and start using new table with new name with all the same data. It's not very cool, but usually it works. Extra backup also won't work because it needs write log. By the way, handler socket is a standard plugin, so as seen on the internet, this usually hangs the entire MySQL process. Along this chapter, using handler socket. So you get two ports open, 9998, 9999, and 9998 is for read-only requests. Workflow is simple. Client opens connection, sends request, then it gets response, sends next request, and get next response. So for one request you get one response, one after another, but you can send a couple requests in bulk and you will receive the same amount of responses in the same order of requests. This works okay. Protocol is text-alike. You can even access handler socket and debug it via telnet, but in fact it's binary. All the requests and responses are one line. This line ends with new line character and consists of a set of tokens separated by tab character. Token is either null or an encoded string. Null is just encoded as null character, and strings are encoded this way. Empty string is just empty token. Then every byte in the range between 0 and hex F is prefixed by 1 and shifted by hex 40. So for example, 3 becomes 143. Other bytes are left unmodified. And as a special note, tab or tab new line means there is an empty token between them, so it's an empty string. Example command: 0 tab, 3 tab, 0 tab, foo tab, new line. This is one command, one line. Tabs are separators, so you get 0, 3, null, foo, and empty string. It's not that complicated. Error responses are the same for every command. They just differ in error text and in error code, which is always greater than 1. Or greater than or equal to 1. Error text is usually some crappy stuff. Unclear. So, handler socket command set. The first command you need to know is openIndex. To work with any table in handler socket, you have to first gain a so-called index. It's a descriptor to special kind of lock on tables. So you open a table, get a descriptor, and work with it. You don't specify table name, its index name, database name anymore. You just specify this index ID. The command is a little bit complicated, but still it's simple. Letter P, index ID of your choice, can be any decimal, database name, table name, index name, a set of a list of comma separated column names you will use for retrieve, insert, and set. I will explain it in the next slide. And the same list, just column names you will use for filtering, like in where condition. And note that F columns is optional. To be more clear, openIndex is some kind of prepared statement for select, insert, delete, and update at the same time. So index ID is 1, database name is test, table name is store. For index you use primary if you need primary index. Columns are ID box, like a select ID box in select clause. And filter column is fruit, which is used in where, like used in where clause. Primary index also gives us additional filtering by the ID field which forms this primary key. Always remember it. You are always working with index and filtering results first of all by index. There are some special notes. First of all, you can reopen index with the same index ID and possibly other database table or whatever. You can open the same table, the same index multiple times with different index IDs. This works okay. You can't manually close indexes. That's very pity, but it is as it is. So when you close connection, index will close after some time, but indexes belong to connections. Two separate connections can have the same index ID specified for completely different tables. This will work okay. When you close connection, you forget everything which belonged to this connection. Open indexes consume memory and consume memory badly, so this makes things work slower and sometimes can eat like 32 gigabytes of data, of memory. Try to use less than 1000 indices, this will work okay, you will have no problems and no big memory usage. For efficiency of inner processing, please keep index ID as small as possible. Insert command. Previously open index ID, plus sign, length of values, and the actual values list. Please always provide all values for columns you specified in columns parameter when doing open index. This is commonly known bug of handler socket. Simple example. You open index number 89, database test, table HS4, primary index, and you work with this set of fields. So 89 plus 4 is the length of trailing parameters. New York A1, Melbourne 4, and you get 0, 1 as a response and 1 as last insert ID in response. Then you insert another row with warehouse New York, box A2, fruit melon, and count 4 and get next last insert ID. So it works clearly and cleanly. Get request. It's one of the hardest. Previously open index ID operation, which should be one of these. Values length must be lower than or equal to number of the columns which form index you are working for. So usually when you work with primary index, you are working with one column. If you work with multi-column indexes, values length should be lower than or equal to count of the columns in the index you opened. And V1 and Vn are column values to look for in index. For multi-column indexes, you can only look for either first column or first and second column, or for three field, either first and second, first or first, second and third. You can't look for only third values. Index is tree-like, so you are descending the tree and you specify values from left to right. This is a little bit complicated. And optional limit clause, in clause, which is broken, we won't discuss it, and filter clause, which can be used multiple times. Both limit and filter and in clauses are optional. Usually you don't use it. Example, we open the same index. Index ID number 88. Operation is equal, so just give us the row that is equal to ID value 3 and length of values is 1. Just we specify only one values because the index is single column index. Then we get 0, like positive result. 4 is count of the columns you opened and you are retrieving also. Warehouse Virginia, box A1, fruit grapes, and the count is 5. A limit clause, it works the same as in MySQL world, just two simple fields, limit and offset, except that if you don't use limit clause, it works as if 1 and 0 were specified. In clause is applied after filter, so when you filter results, you will get limit number of results equal to limit or less, if there aren't any. Harder example, the same index, 89, give us all rows with ID 2 or greater than ID 2, limit 3, offset 0, and then you get 1, 2, 3 results. Note that column count is still 4, or otherwise you wouldn't equally treat the result. So this is warehouse Seattle, box B1, banana 4, and here's the next result with count 5 and the third result. Filter clause is harder. Filter can be either F, it skips unmatching rows, or W, just stops at first inappropriate row. Operation is one of equal, not equal to, less, less than or equal to, greater, greater than or equal to. Fcall field must contain number of the column from F columns list in the previously opened index, only one number. And fval is actually the value we're using for filtering. You can specify multiple filters, like in where condition and, they all work as logical AND between them. Update delete is all the same, except limit is required, and you need to specify update or modification operator, modification clause. Modification clause, very simple. Modification operation and a set of field values, which should be less than or equal to number of columns from opened index. Operation can be update, delete, increment, decrement, and their variants with question mark in the end. Operations with question mark return row values before modifying the actual data. So it's consistent get and update request. If you don't use question mark, you just get a number of updated or deleted rows as a result. There is a little note on decrement operation. It doesn't change the sign of numbers. I mean, when the result will change sign, it won't work. It just won't work if you're trying to decrement more than the final result will be 0. For increment and decrement, obviously, your values should be numbers. Example, with filter. You open index number 90 to work with column count and without filters, sorry. To work with column count with no filters. Then you search for value number 8 in primary index, just one row. Specify obvious limit 1, offset 0. Modification operation is increment and return results before incrementing, and increment by 10. So you get count, which is being incremented first 6 and then it becomes 16. Another example with filter now. You open the same index but specify count as a column list for filtering also. Then you search for index ID starting from greater than 0, so starting from 1, 2, 3, 4 and further. Limit 1000 rows, offset 0, and then you filter 0th column from this list, it's count. So you filter by count using filter. It's a filter that just skips inappropriate rows. Greater than 3. Count should be greater than 3, and a modification operation is delete. So you delete rows with ID greater than 0 and count greater than 3. And then you get a standard result with a number of rows deleted. So we deleted 5 rows. As a conclusion, limit offset is limit clause. In clause, in statement is in clause. When you need to select ID between 1 and 2, you make an index on this column and select with index greater than or equal 1 and specify an additional W-type filter which processes rows while ID is lower than or equal to. This is actually like the same variant. you need to filter by two different fields. First one should be lower than 1 and second one should be greater than 2. So you just use two F-type filters by field A, lower than 1, and obviously by field B, greater than 2. And if you need consistent operations like select for update, you use modification operations with question mark in the end. That was hard, right? Let's look on this from another perspective of view, from another point of view. Different handler socket peculiarities. You can read all data types with handler socket, but you can't write timestamp fields. And while writing, the data is treated the same way as in SQL in terms of being cut when it doesn't fit in the field. On update, current timestamp is not working. Char sets. If you work with UTF only, you will have no headache. It works okay. Just please comply with handler socket protocol encoding standard. Blobs are binary fields, so you just read binary data and write binary data in handler socket protocol. That's it. And then handler socket reads and writes fields in the char set of the field. I mean, like in binary mode. So if you mix different encodings, you will read them as is in bytes, and you will have to work with two different encodings in handler socket protocol. Bytes which don't fit in char set are replaced just with the ASCII question mark on insertion or update. So
you have 10 minutes left.
Yeah, okay. Sorting and collations. Collations in the handler socket world affect selection operations, but not filters, and they define the order you get results in. So when you specify lower than or equal operation, you will work with the index reversed. You will get results in reverse order, because handler socket reads records in the order they are stored in MySQL index, and in MySQL world, indices are stored according to the collations of the fields they consist of. So if you form combined index with two string columns, each of them having different char set, they will be sorted according to their char set. Use this link for help yourself. Default values. On insertion, omitted fields, I mean only fields not specified in here, because always provide all data for columns when doing insertion. Otherwise, you get garbled data. Don't try to insert less count of fields than you specified in columns. Fields get their default values, except binary, enum, and timestamp. This is complicated. Try it yourself. Now, as a default value, won't work. I don't know why. This is a bug. You will get a 0 or empty string inserted instead. In all the other means, everything works. Use cases in my company. Use case number 1. Here is a simple band email database lookup table. ID, first email part, second email part, and some supplementary parameters. We originally used SQL layer to access it, then we replaced the simple select with handler socket get. Gained like 10 more select rate. It's just one table, one server in one data center, and this table replicates to the same table in the other data center. We are built-in MySQL master replication. 52 million rows, 5 gigabytes. We use persistent connection. All the data is fitted into memory. I mean in cache, not in memory, but all data is in the DB cache. Finally, on a dual-core standard symbol server, 60% CPU is used, and we get around 1000 selects per second with average 3 millisecond average read time. Inserts and updates are very rare, and they go via SQL layer. Use case number 2, persistent session store, just a key value store, key and value. Key is generated randomly. Simple operation, just select, insert and update only one row by key. Periodically we purge obsolete data via SQL layer. One table, one server, 16 million rows, 23 gigabytes, feed it into in DB cache, sorry. So finally on a 12-core Intel server, around 8% CPU used, and we get around 3,500 RPS with an average request time around half a millisecond. Originally it was around 4 times slower, and we started moving from MySQL to Percona server with its extra DB tables, and this gave us 4 times more performance. Use case number 3, sharded persistent store. All the same, except key is consists of 2 columns, but also now we sharded this table in one server across 10,000 tables in 100 databases. IDs are generated randomly. Data is pretty the same, but results are 3 times slower. You will ask me, with the same CPU load, results are 3 times slower. You will ask me why. I will first show you the graphs. This is the average read time, write time, and create time. You can notice RPS values are floating, but time is around the same, between 1 and 2 milliseconds. And here is an answer for sharding question. It has 2 problems, like resolves 2 problems. First, when you use one table, it works well until you need to write a lot of data. Then it becomes a single hot point. And the second problem, when a table grows, indexes grow. There are like tree structure grows. So performance drops very rapidly. So please clean obsolete rows daily to make table compact on the disk. And try sharding to make indexes have less structure. Final use case is a persistent cache. We replaced memcached with this handler socket solution because memcached reinitialization was very long during reboots. So we made a persistent cache which serves the same needs. Only key value operations like in memcached, get, set, modify, that's it. The same sharding setup, sharded across 10,000 tables, 32 million rows, 14 gigabytes data set, everything fits in memory, and all the same server with 11% CPU use, but with completely other load, we get around 14.5 RPS reads, like 14,500 reads per second, with the same half a millisecond for an average request time. Here are the graphs. You can also note that read times don't float in some small corridor. They're like all the same, despite of floating RPS values. Tuning handler socket, just like final 4 slides. Try to shard by key. Use extra DB. Use persistent connections, they will give you lots of performance. But there is one problem with persistent connections, one hard point. When you work with like a general web server request processing manager like GUnicorn or PHP FPM or another software, with persistent connections you will likely inherit an open socket from the previous request. So PHP FPM starts processing request, opens a socket, works the handler socket, then it leaves socket open, starts processing new request with completely resetted like global variables and all the request data, but you get the same socket. So it's possible that in this socket you can read response from previous request which timed out or wasn't completely fetched out of from socket. This is a big problem for handler socket protocol because requests and responses don't match each other except one by one. There is no IDs. You can't securely guarantee that this response is for this request. So I usually use this technique. Instead of reading value by key, I read key and value, where key is something. And check if key matches requested key. It's not 100% guarantee, but it solved our big problem when once we logged around 1,000 users in wrong accounts. So finally it makes me sleep at night, makes me a good sleep. And also, to avoid this problem, reopen connections on every syntax error and I/O error. Try to work with sockets at as low level as you can. Write your own client library. Prevent passing socket with data to next request. Close it at the end of request, mark it as not completely clean and close it. Develop your own client library. What else you can play with? This is not covered. Row format, key block size, using hash indices, and the final is merge several small indexes into one big multi-column index and to work with it if your business logic allows it. Usually it helps. Final part. 2 FAQ questions. Should I use client library on my own or just download from the internet? My answer is simple. If you plan on using persistent connections, definitely check the code you will be using for it to meet the requirements from the last slides. If you don't plan on using persistent connections, don't write your own library, just get some from the internet and it will work okay. And the second question is, why should I use handler socket instead of Redis and normal NoSQL world databases like MongoDB? It has 2 answers. First of all, there are lots of companies that can't abandon MySQL entirely. They need SQL access layer, and this usually helps. And the second, handler socket gives you all good SQL benefits from MySQL world, like ACID, transactions, not transactions, but f-syncing data to disk, control of transactions, lots of different settings, lots of cache control, good multi-core scaling, it works okay on our 24-core servers, and very efficient data packing. Further reading, don't write this down, I will give you all the slides. Thanks. Here's the link, bit.ly luck 2012. Slides made in Brazil. Thanks a lot for listening. Questions? There should be plenty of.
How do you do to be sure all your data are in InnoDB cache?
Okay, the question is, how do I ensure all the data fits into cache?
Yeah.
There are special show database status request, and this can be easily figured out from on the internet how to do it. It's simple. Just check the amount of data used and amount of cache you dedicated for cache. If cache used is lower, everything works okay. And finally, you will notice it very quickly. When your requests go like 1,000 times slower, this is the first answer. Handler socket has no joins, no complicated subqueries, so it doesn't use temporary tables, it doesn't use join buffers. Most of the things I avoided just by design. It's not good, but it is, as is. Yeah, next.
Let's say.
Sorry, yeah.
Does it work with Galera?
No, sorry.
Is performance comparable to Redis?
Protocol is not comparable to Redis at all.
The performance.
Performance for me, replacing Redis with handler socket gave four time like I made things 4 times fast, but this was mainly because I needed to write a lot. So unsharded, one simple table scaled across 4 cores, and in Redis, like 2 years ago, it was only single core, so you had to invent your own sharding. I was lazy, so I used the big server with 1 core, but finally replacing Redis with 4 core solution gave me 4 times more RPS. Yeah.
Do the threads, internal worker threads, group write into transactions?
Okay, I will repeat the question. Do internal write threads group requests in transactions?
Yeah.
Yes.
How does it solve the conflict then? So you can have like 100 write requests group transactions. Does it handle the conflicts?
It's an interesting question, but mainly by design, all of the complicated stuff is avoided. You can read and write only 1 row, and you can update only 1 row. So the only conflict you can gain is when you try to update the same row in the same table with handler socket. I can't answer it right now. I need to check the handler socket sources really to read the C code. But I think it's not a big problem, because in all my setups I always work with the same tables and with lots of requests. So write me an email, I will check it. Looks like it just applies the last command, and that's it, in the same transaction. Somehow resolves it.
Perfect.
Okay, that's it. Okay, thanks for listening.